Okay, so with number 11, we have a bonus question here. We just need to determine whether this following series, so we have cosine of n pi divided by n squared. We need to know if this is absolutely convergent, conditionally convergent, or divergent. So what you first want to recognize here is that since we have cosine of n pi, we are always having multiples of pi, and therefore this is always going to be negative 1 or 1. And in fact, if you think about this, when you plug in 1, we get cosine of pi, which is negative 1. Cosine of 2 pi then would be positive 1, 3 pi back to negative 1. So cosine of n pi, as long as n is integers here, this is just alternating. You don't need to, it's just a tricky way of writing that, essentially. But you do need to keep in mind, now in this problem it actually ends up not mattering, but just for future reference here, you need to make sure you start on the correct one. N being 1 makes this cosine of pi, which is negative 1, so you have to start with negative. So you can't just put negative 1 to the n minus 1, like or the n plus 1 like you usually did. Since this is n equals 1, we can have this as n, because that means when n equals 1, negative 1 to the 1, that's negative. We have to make sure we're negative first. So these two things are the exact same. And now this question probably becomes pretty simple. Is this convergent, absolutely convergent, conditionally convergent, or divergent? Well, the best way to do this is, since the rest of the function other than the alternating is very easy, it's just 1 over n squared. You know that converges by p-series. So if this converges even if it's not alternating, it definitely is going to converge if it's alternating. This is the definition of absolutely convergent. So if you have an alternating series and the series without the alternating part converges anyway, we have absolutely convergent here, so that's answer choice C.